Hi students, this is Miss Witt. This was your homework tonight. It was on the shapes of and analyzing numeric data displays. We focused mostly on the dot plots. Today we did not do the oops, I did not charge my pen. Let me charge that while we're talking. We focused mostly on the dot plots, and I didn't focus on the stem leaf. We'll do that probably tomorrow. We talked about the different types of distribution, which would be symmetric, which if it's symmetric, it goes up to a point like a mountain. If it's skewed right, it means it starts to the left and it goes down to the right side. And if it's skewed left, the data starts high at the top and it goes down to the left. So there's some examples of this. I'll show you in just a minute. We'll talk about clusters, gaps, peaks, and outliers. So as I go through the screens, I'll talk about each of these. So on the first screen, this was talking a little bit about dot plots, and we talked about which conclusions we could make about the number of total medals won at the 2014 Winter Olympic Games. And we had to use the table from this, I believe, that had the Olympic Games medals. And so what we concluded was that the Russian Federation won the most medals, as you can see here. So as we go back, I'm kind of going to have to switch back and forth here. As we go back, the second question said, are the data in the table categorized or categorical or quantitative? And this goes with what we talked about yesterday. It was definitely quantitative because we saw numbers, and that was explaining our reasoning. We didn't see categories, we saw numbers by the medals. Are the data in the table discrete or continuous? They were discrete because they were exact whole numbers. They did not continue on. So that is why. If we go to the next page, this is where we showed an example of a dot plot. I talked about this in class, about the dot plot. It can be displayed with dots, X's, for example, like what you see here, or with other symbols, probably like what you saw on the first page. Dot plots help you organize. It's kind of like another way, almost like a bar graph or a circle graph. So we're supposed to use this dot plot above to answer the questions. It says, what do the two X's above the number 8 represent? The X's represent the medal winning countries, okay? And the numbers represent the gold medals won. So that's very important you understand those titles and what each thing represents. So we know that there's two X's above the number 8 because 2 countries won 8 medals. What do the 5 X's above the number 0 represent? It means because there are 5 countries, I'm writing fast, sorry, that won 0 medals. Then it says use the dot plot to determine the number of countries that won medals. So you're really supposed to add up all the X's or count them. And there are a total of 26 X's. But if we're being technical, we can't really count these 5 because they did not win any medals. I think they should have worded it maybe, oops, you know what? I skipped a spot. That 26 should go here. My bad. That 26 should go there. But technically, it should be that there's really 21 that actually won gold medals because 5 of them won 0. Why are there no X's above the number 7? Because no countries won 7 medals. Okay, so we basically just analyzed a dot plot and read it. Going to the next page, make a plan for creating a dot plot. So usually you have to have a name. What will you name your dot plot? And so they ask us to refer to one in the class. We could technically do a dot plot on, if we wanted to, we could do a dot plot on, let me think, sports, if we wanted to, so we would call it favorite sports if I wanted to make up my own. What numbers will begin and end? So obviously it'd be 0. And we could say, how many sports you play. It could be all the way up to maybe, you kind of collect your data and then you go from there. So if I collected my data and let's say the most sports that some people played were maybe 5 at one, 5 different sports. So then it says what interval will you use on your number line? You can count by 0, 1, 2, 3, 4, 5 and make your number line just in numerical single intervals. On your homework tonight, you're definitely going to want to maybe do intervals that are a little bit larger than single intervals, like what I just have right here. You might want to do like a range on your homework tonight because you're going to see when we get to that page that you're going to have high numbers. Create your dot plot displaying the data for the total medals won, which I decided to change this because we already talked about this in class, and I said let's talk about sports. And so let's say I make my dot plot and I have down that 0, 1, 2, 3, 4, and 5. And let's say I was collecting data and I have my little checklist here. I have off to the side I have 0, 1, 2, 3, 4, 5. And let's say I asked my AC class, I went through each student and I said, how many sports do you play? And when I got done interviewing everybody, I had 3 students that played 0 sports. I had 1, 2, 3, 4, 5 students that played 1 sport. Here I might have maybe 2 people played 2 sports. I had nobody play 3 sports. 1 person played 4 sports, and again, nobody played 5 sports. So I have a pretty small AC class, we'll say, and so I would label at the bottom of my dot plot number of sports played, and at the top I would maybe refer to it as number of students, because the X's are going to represent the students that play those number of sports. So above the 0, I would put 3 X's or maybe 3 dots. Above the 1, I'm going to put 5. Above the 2, I'm going to put 2. Above the 3, I'm not going to put anything. And above the 4, I'm going to put 1. Now, if I was looking at this dot plot, I can already tell how it's skewed. It is not symmetrical because it does not go up to one point in the middle. As I'm looking at it, I notice that it's kind of going down like this, which tells me I can already tell it's right skewed or right tailed. So that's a good way to understand your distribution of your data. So if I go to the next page, it kind of talks a little bit about that. Describing distributions. Can you analyze a graphical representation of numeric data? You can look at the shape, the center, and the spread to draw conclusions. What is the overall shape? Basically what we talked about, was it symmetrical? Is it skewed right? Or is it skewed left? What does the graph tell me about how the spread is? Are there clusters? Are there gaps? Are there outliers? So there are clusters, meaning are all the X's clumped together in one spot? Are there gaps in between the X's? Or is there an outlier, which means, is there like an X if I have all my X's like this? And then I have a big outlier way out here by himself. He's an outlier. The overall shape of the graph is called the distribution of the data. A distribution is the way in which the data is spread out. There are many different distributions. The most common, like we talked about, are symmetric, skewed right, and skewed left. If you look at the next page, they show you some examples of these. This is symmetric, where, oops, I think the computer's trying to catch up. There we go. Where it's skewed different ways. So, oops, I don't think I can bring this down. Oh, there we go. So you can see right here, it's skewed and it goes up to a point like a mountain, like I said. Now, one thing to be careful, because my students thought that since it said a mirror image is on each side, obviously this one does, oops, let me erase this so you can see it better. This side does not match this side exactly. And as you can see, there's two here and only one group of two there. But in generally, it goes up to 1 point. This is skewed right because it goes down to the right. And that's why sometimes they call it a right tail, because the tail goes down to the right. This one is skewed left because the tail goes down to the left. They say here a peak is usually the value with the greatest frequency. So obviously this would be the peak here, this would be the peak, and this would be the peak. So there's some, that describes the distribution. If you go to the next page, we talked about some distributions of the data plot. If I went back to my sports one, we already talked about that one. We said that the distribution was right-tailed or skewed to the right because it went down to the right. And then now we're going to talk a little bit about the clusters. They're areas where data are grouped close together. So you're going to have a bunch of X's or dots clustered together, and then you might have some over here. Whoops, my X's are not very good. So we have a cluster here, and we might have a cluster over here. A gap is when there's no data, like right there. That would be a gap. Peaks are where the highest point is, which would be right here. Outliers would be one that's way out by himself. So if I had an X way over here to the left, away from all the other ones, he would be an outlier. I'm a large distance from the other data. So they ask you to answer some questions here, but we're going to move on to our homework questions. Oh, I do like this page, the Talk to Talk. These show some different examples here. So if we're looking here, you can see that they're talking about clusters here. There's a cluster here and a cluster here. You can see that there's a gap here. You can see that these are some little outliers. Okay. For this one, they're kind of showing plot B that it's right-tailed. Oops, getting low battery. They have this one on its side, but they're showing that this one is definitely a symmetrical, because it goes to a point, even though it's on its side there. They're showing this one is left-tailed, so this one is right-tailed or right-skewed. This one is symmetrical, and this one is left-skewed or left-tailed. This one is showing that there's some more clusters here and clusters here. And of course, we have a little gap in the middle there. So there's some data examples for you to see. Again, we have some peaks. This one definitely has a peak right here. This one has the peak right here. Obviously, this one is the peak. This one looks like it has 3 sets of peaks. This one looks like it has 2 sets of peaks. So hopefully you can see some of that and see some examples. And this is which plot or plot illustrations illustrate each graphical feature. So plot A shows clusters, plot B shows some gaps. C, so we have some outliers. Oops, I don't think this is referring to the plots. They're just asking you to find them. All right, we're going to look at your homework real quick. So this is what you're supposed to use for your homework tonight. It says use with an assignment, with the assignment tonight. So on the first part, it says write the definition. So you're going to find, I know I saw the definition for dot plot, distribution. I saw these definitions. Actually, I saw all of these. The only one that you don't have to do is stem leaf plot, because we didn't cover that unless you want to. The first one says create a dot plot on the number of wins. Be sure to name it. So if I'm doing a dot plot, I would start off by maybe making my line across the bottom, and we're going to do number of wins. And if I go back to my table, I see that here are my wins, okay? And then we have our seasons. So so the top part of my graph is going to say seasons. So, and then I look at what is my lowest number of my wins, and I see a 13. I think that's it. So I could probably start at 13. It looks like my greatest number I saw a 60. My greatest number might be 60. Yes, so I want to make it from 30 to 60. And so I'm going to go back to my page. I want to have some room. And up here I'm going to write seasons. And I'm going to go from 30 and we're going to end at 60. So I might go like this. I might say 30 to 35. And maybe here I'm going to go from 36 to 40. These are my intervals. Remember we said you don't have to do singular intervals. This might be from 41 to 45, maybe 46 to 50, 51 to 55, and then here 56 to 60. And then I can put my X's above. So I'm going to go back to my chart and figure this out. So my first one was from 30 to 35. So 30 to 35, I have wins here. 30 to 35, I have 1. Oh, you know what? We weren't supposed to start at 30. I messed up. We should start at 13. Oh, I need to go back and fix that. Sorry, guys. Let me go back and fix that. So I'm going to have to erase this. We start at 13. So maybe I need to do like 13 to maybe 23. I'll go in increments of 10. And then 24 to I'm changing my mind. I think I'm going to do 13 to 20. And then I'll do 21 to 30, then 31 to 40, then 41 to 50, and then 51 to 60. There we go. So let me go back to my chart. And so I see let me erase this. So I see I have 13. So I'm doing 13 to 20. So I have 1. Might just have 1. Yep, I just have 1. So I'm going to go back over here and put 1x above the 13 to 20. Now I'm doing 21 to 30. So I'll go back and I look from 21 to 30. So I'll look 21 to 30. Whoops. I don't want to count that one. Oh, there's 1. I'm going to do a different color for this so we can kind of figure it out. So that will be 1, 2, 3, 4, 5, 6. I think I just got 6. So I go back to my chart and I'm going to put 6 dots or X's. 1, 2, 3, 4, 5, 6. Now I'm going to look for 31 to 40. It's a lot easier if it was side by side, like you could have on your paper in front of you. So 31 to 40. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I can put 15 X's above the next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Almost ran out of room. Now I gotta do 41 to 50. let's do green. 41 to 50, that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 X's. Oh, wow. So there'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And this actually should go a lot higher. And that's not going to be able to make mine as high. But it's going to be the highest one because this one is 19. I'm just going to write that there so I can remember that. 19. Now I need to do, my screen's not big enough. Now I need to do the rest of them, 51 to 60. So how many will that be? I think I'll do this one in black. 51 to 60. So 1, 2, 3, 4, 5, 6, 7, 7. So when I go back, I just only need to make 7 X's now. Whoops. 1, 2, 3, 4, 5, 6, 7. So that took a little bit of time, but we did it. And that's what you have to do for question number 1. Now, if I go to question number 2, it specifically says, describe the distribution of your data, include specific graphical features or patterns. So now if I go back and I look, I got to write down the distribution. How was it skewed? Was it symmetrical? Was it skewed left or was it skewed right? And I'm looking and I see that it is skewed definitely symmetrical. So I'd write down symmetrical for number 2. And I didn't see any gaps. I did see a little bit of a cluster in the middle. So I saw one cluster in the middle. And I would say that my peak was definitely this 41 to 50 was my peak because that one went way above what I could even go up on here. So that's definitely my peak. So now when you do the next part of your homework, it asks you to do it now the same thing for number 3, but you're going to do it with the losses. You're going to need to make another chart and do it with the losses. And then also tell me the patterns and how it was distributed, whether it was skewed to the right, to left, or symmetrical. I told you today that you did not have to do number 5 on your review. You did not have to do stretch, but on the review I said you did not have to do number 2. You need to do number 1 and you need to number 3A and 3B. I hope this helps you a little bit tonight, and we'll talk more about it tomorrow, and have a good night, guys.